Okay, so we're going to come back with a short little review concept from Monday's class session, right? We talked about how we have this process where we want to um, um, plan and develop strategies, and we will direct the activities from our once we've decided on an option, we'll implement the option, which is directing our activities, and then we would evaluate after the fact to determine if our choices, our strategic choices, were correct. And part of that activity to plan is to look at the different choices that we have and decide which ones are acceptable and which ones are not. And so on Monday, we talked about the payback method, and we talked about the accounting rate of return and how those are two non-time value of money methods for determining if projects are acceptable. And then we also talked about how if you have more than one project that is acceptable, how you would want to rank those in order to figure out from best to worst which ones would be the ones you should select. So here we've got 3 different projects, and they've provided us with the accounting rates of return for these 3 projects. So I want to have everybody take a second and look at these and figure out, okay, which ones of these are most desirable to least desirable based on these rates of return, and then determine which of these would be acceptable or not acceptable. So take a second and go ahead and take a shot at those, and then we'll go over these in a second. I would like you to take a moment to think about which ones are acceptable versus not acceptable based on an 8% required rate of return. So it shouldn't take too long here. All right, so in order, right? Obviously, higher rate of return is better. So therefore, our highest ranking one would be Project X. Our second would be Project Z. And then the lowest of these would be Project Y. And then can I see a show of like hands raised, like who thinks that Project X is acceptable? So use the hand raising feature or the response feature. I got one person participating. Anybody else? Okay, so if our rate of return here is 13.25%, and we need to have a minimum of 8%, then that would be acceptable, right? And then in terms of Project Y, that has a 6.58% rate of return, which is below our cutoff of 8%. So we would reject that one. And then again, 10.47 is better. So we can go ahead and accept that one. All right. So that was just a quick review from what we talked about on Monday. And let's see here. So when we are looking at projects, we're going to start talking about present values here and how we use the time value of money to analyze some different projects. So I'm going to just pull up my slides here really quick. And I'm hoping, yay, it's actually coming up. You guys can see the slides, right? Okay, thank you. All right, so we talked about in chapter 14, the time value of money, and we talked about bonds. We talked about how figuring out the value of something today is its present value, and then figuring out what something worth in the future or at a later date is a future value. And then we talked about how you can calculate those present and future values for either one lump sum of money, or you can do it for a stream of equal payments. Or if you have a multiple different unequal payments, you can use the lump sums in order to calculate a total of multiple different cash payments. And so we're going to learn how to apply that to project decision making in the rest of this chapter. And we'll do a little bit of that today, and we'll do a little bit of it next week. One second, let me close my door here. Apologies, I have some little voices out in the hall. Okay, so there's two methods that a company can use in order to figure out the value of an overall project, right? So when we look at projects, capital budgeting projects, they would consist of an initial cash flow when we spend money out to buy something, and then a stream of cash flows, which would be things like income that comes to us, expenses that we pay out, and then at the end of the life of that project, there would be theoretically a disposal cost, right? Or like maybe it's a cost where we are like, oh, we have a mess. Like we have an environmental project that's going to have to be cleaned up at the end. That would be a cost at the end. Or maybe we have a piece of equipment that we're only going to use for a certain amount of time. And then at the end, we would sell that off, and that would be a cash flow to us. Either way, what we're doing here is we're breaking up all of our components of our project into cash flows, and then we're using the time value of money to value those. And so we're going to talk about a couple of different methods that we can use for that, which are net present value and the internal rate of return. And that'll be sort of the culmination of this time value of money section. So just reviewing back to some of our time value of money concepts, a principal amount is the amount that we're trying to figure out whether it is what it's worth today or what it's worth in the future. So we've got, and that's usually a present value. And then in addition to that, we've got the number of time periods that are going to be associated with a project. And then we've got an interest rate that's associated with that project. So we talked in our time value of money chapter also about simple interest that is calculated versus compound interest, where you earn interest on your previous interest earnings. So I'm not going to go through that too much here because we already had a section on that a couple weeks ago. But just remembering that, like, if we have $10,000 and we calculate simple interest on it, it would just be the same amount every year because we're taking our base $10,000 and figuring 5 years at 6% would be $600 a year times 5, which is $3,000. Whereas if we compound that and we calculate interest on the interest, each year the amount of interest we earn goes up slightly. Okay. So we would actually, with compound interest, which is more of the real life example, earn $3,383. Okay. So jumping forward past this, I already talked about those. When we have a single amount that's a lump sum, we can calculate the present or future value of that using the tables that we used in our earlier chapter. Or we could have a stream of equal payments over time at regular time intervals, which is referred to as an ordinary annuity. So hopefully all of this is sounding familiar from our chapter a couple of weeks ago. So what I want to do is I want to look at a really quick compound interest example in problem number 7, where we're going to calculate out using our tables the value of $1 in the future and what it would grow as in using compound interest. Okay, so we've got $1, and we want to know if we have an 8% interest rate. Oh, sorry, I got that backwards. We're doing present values. We have $1 that we're going to receive 1 year from now, and we want to know what it's worth in terms of today's dollars, which would be the present value. So we're going to look at our present value table here, and since this is $1, we are going to look at our present value of $1 table, and I'm going to make this bigger to take up a little more room here. And we see here, if we're looking at 1 year, one time period, and we are looking at 8%, the value of that $1 at the end of 1 year is going to be 0.926 here. And then at the end of 2 years, the present value, so the value of $1 received 2 years from now in today's dollars would be 0.857. So we're going to say, all right, the value of $1 received in 3 years would be 0.794. And then the value of $1 received in 4 years is 0.735. And then the value in 5 years would be 0.681. So basically, another way of saying this is that if I want to have $1 1 year from now, how much would I need to invest at an 8% interest rate to end up with $1 in a year? So if I were to take this 92.6 cents and invest that today, whoops. So if I take 0.926 and I grow that for 1 year, it would be 1.08, 1 plus 8% at the end of that year. Which would be basically $1 here. Oops, I accidentally wrote over that space. But so we basically have $1 in a year. And if I were to take 0.857 cents and invest that for 2 years, I would end up with $1. If I was to take 0.794 today, 79.4 cents today, and invest that for 3 years, I would end up with $1. All right. So we can look at this in both directions. Now, if I were to get $1 each of these years in a year from now, 2 years from now, 3 years from now, 4 years from now, and 5 years from now, what I would need to do to invest in order to get each of that stream of cash flows, $1 a year for 5 years, I would actually, let me do this in Excel. Here, I'll close this table. Okay, so if I wanted to invest in order to get $1 a year for 5 years, the amount that I would need to invest at 8% interest would be 3.993. Now, this right here is a stream of an ordinary annuity, $1 a year received for 5 years. If I look out at my present value of ordinary annuity of $1 table here, and I go to 5 years and 8%, we see that the amount on this table is 3.993. So that's how this table is calculating these factors. And this problem is just showing us that the value of an ordinary annuity, the present value of an ordinary annuity, is equal to the sum of the present values of each of those cash flows that we would receive. So this is the value of a cash flow of $1 received a year from now, the present value of a dollar received 2 years from now, and so on and so forth. The value of this entire stream in today's dollars is $3.99.3. To describe this as an annuity, this is an annuity because it is a stream of equal cash payments made at equal time intervals, so every year for 5 years. Okay. Let's see here. So let's look at, let's see, this was problem number 5 we just did. Let's see here. Oops. Hold on. Why did I not complete here? Oh, I didn't check my answer. Oops, what did it? Oh, I missed part of it. I didn't do that. Okay, so the present value of $1 received each year for 5 years at 8% per year is 3.993. And so it equals so the sum of the present values that we did in the first part equals, except for a possibly slight rounding difference, that same present value. And it shows how annuity present value factors are the sums of the present value factors found in the present value of $1 tables. Okay. Let's see here. Oh, that's not the one I was looking for. Okay, so let's go to problem number 8, which is another time value of money example here. So we've got a grandfather who would like to share some money with us, and he offers to give us money under one of the following scenarios. We can either get $8,750 per year at the end of each of the next 7 years, or we can get a lump sum of $50,050 now, or we can get a lump sum of $100,250 7 years from now. So how would we go about figuring out which of these is the most valuable overall? Well, what we want to do is we want to calculate the present value of each of these scenarios to figure out what it's worth in today's dollars. And then from a financial decision-making standpoint, we would choose the one that is worth the highest dollar amount, okay? So let's go ahead and look at this. They've given us our 2 tables here. And I'm gonna make this Excel one a little narrower because I don't need it that wide. I'm gonna make this one wider so I can pull up my table here more easily. Okay, so calculate the present value of each scenario using a 6% discount rate. So essentially what we're doing here is we're going to figure out what is this worth today if I believe that I can get a 6% return on funds that I were to invest right now. Okay, so the first one is $8,750 per year at the end of each of the next 7 years. So an amount received annually for 7 years is going to be an ordinary annuity. So we want to use the ordinary annuity table. I'm just going to put ordinary annuity there. And it's the value of that is going to be $8,750 for 7 years. So, and we're going to calculate our present value here. All right, so looking at our ordinary annuity table, we're going to go to 7 years and 6% here. So 7 years over to the 6% column gets us a factor of 5.582. And so we're going to take this amount and we're going to calculate it or multiply it times 5.582. So take the amount of your annuity, multiply it times the annuity factor. So, and then they want us to round it to the nearest whole dollar. So 48,843 is where we're at here. So in terms of today's dollars, that would be worth $48,843. All right, so our next scenario then is a lump sum today of $50,050. Well, what it is, if it's given to us today, that's what it's worth today. There's no discounting going on here. Like somebody handing me $50,050 today is worth $50,050. Right? And then this last one is a lump sum 7 years from now. Okay, so so in 7 years, we would be receiving $100,250. And so we would go then, since this is a lump sum, to this table right here. And we're going to again look for 6% and 7 years. So 6%, 7 years gets us 0.665. So we're going to take this future amount that we would receive and discount it back into today's dollars. So that one is going to be worth $66,666 in today's dollars. Okay, so go ahead then. Or actually, we'll do the second part in a second here, but which one of these is worth the most money? That's the one that we would pick. So it appears to me that scenario 3 is the best option because it has the highest present value. Okay, so would our preference change if we used a 12% rate? Well, let's do the same thing again here, but with a 12% rate. So looking at 12% and 7 years, we have 4.564. Oops, hold on, wrong line here. Should be up here. There we go. So 8750 times 4.564. So 39,935 in today's dollars. That one is again going to be for the second one, again, still worth the same amount today. And then this one, discounting this one back, 12%, 7 years is 0.452. $45,313. Well, now we have a different situation here. So now the lump sum scenario 2 appears to be the best option if we can get a 12% rate because that one has the highest present value. And the reason for that is because, so up here in our earlier one, right, if we can only get a 6% return on this, it's not going to earn us at the end of 7 years. We would not, if we took this $50,050 and we invested it at 6%, we would not end up with $100,250 in 7 years. It wouldn't grow fast enough to get that amount. And looking down here, if we were to invest that $50,000 um, or if we were to invest $45,000 only, we could get the $100,250. So if we were to take $50,050 and invest it at 12%, we would actually end up at the end of 7 years with, let me run this here. Let's do 12%, 7 years, no interim payments, $50,050 invested. We would end up with $110,000 at the end of 7 years. We would be better off taking this and investing it at 12% and ending up with $110,000 at the end of 7 years than waiting to get this amount at the end. Okay. So that's the math behind what is going on here in terms of the decision making. Okay, let's see here. I did 1 and 2. Let me just check these really quick here. Okay, so let's do problem number 3 then. And then I think we'll wrap up after problem number 3. So this is just another time value of money example here. Calculate the present value of $5,000 received in 3 years with interest of 10%. So go ahead and take a second and do this. I'm going to stop sharing for a second and do this myself, and then we will go ahead and come together here in a second. But take a second and just make sure that, test your knowledge and your ability to use the tables and solve this. This will be very similar to what we did. Actually, just do the first 2, and we'll do the third one here together, because that's the mixed cash flow one. So just do the first 2. If you want, you can start on the third one, but I will walk through that one here. Okay, so here is where I ended up here, right? So we took the future value of $5,000, multiplied it times the present value factor from the table, looking at the intersection of 10% and 3 years on the present value of $1 table. We had a present value of $3,755. And then we calculated a present value of a $5,000 ordinary annuity received each year for 3 years at an interest rate of 10%. So the amount from the present value of annuity table was 2.487 at 10% and 3 years. And so that got us to 12,435. Now, for this third one, we have a mixed cash flow situation here, where we've got payments of $2,000, $3,000, and $4,000. And so we want to do these. We're going to calculate the present value of each of these. So we're going to take the future value here times the present value factor for each of these cash payments for 2,000, 3,000, and 4,000. And these are interest rate of 7%. So for the first one, we're going to use the present value table for each of these. And we've got 7% and 1 year we're going to want. So 7% and 1 year is 0.935. And then in 2 years and 7% here is 0.873. And then for 3 years at 7%, it's 0.816. So we're going to go ahead and multiply all of those across. And that's going to get us to 3264. And then the total of those three adds up to 7753. So this is what's called a mixed stream of cash flows, where you have a series of cash flows that are not equal in size. And then so what you do then is you calculate the present value of each of those cash flows and then add them together, just like we so it's the same concept as what happens in an annuity. It's just you have to do them each separately because they each have different amounts related to them. Okay. All right. I think we're going to wrap up on that. I'll give you an extra 15 minutes back. I hope that everybody has a lovely holiday. We will continue on with time value of money and applying these concepts to projects on Monday. Does anybody have any questions before we wrap up? Go ahead and ask if you want, or you can hang around after if you wish, or you can send me a direct chat if you prefer. Thank you. You have a good break too. Happy Thanksgiving, everybody.